what we'll do, we'll start with the first stage. Okay, remember we started with a 90-degree ambient. From there, the air went to the first stage, right up here. It went through the inlet filter, pumped through the first stage up to 40 pounds, and discharged in this manifold. This is where we read the temperature. And that temperature read 315 degrees, pretty hot. From there, we go to the intercooler. And again, the purpose of the intercooler is to cool the air between stages. So we went with 315 degrees air here through the intercooler tubes, which you can see some of them right down in here, and up the inlet of the second stage. By the time the air got through the intercooler, we were cooled down to 140 degrees. Now, 140 degree air sucked into the second stage. Okay? The second stage took the air at 140 degrees and 40 pounds and compressed it up to 175. When it compressed it to 175, it discharged here, and the temperature at that point was 380 degrees. Okay, it's interesting to note a little correlation here. Your first stage temperature rise was 225 degrees, 90 degrees up to 315. The second stage rise was from 140 to 380, which is 240 degrees. So you can see that even though the second stage discharge is quite a bit hotter than the first stage, your temperature rise isn't all that great. They're really just about the same. The reason there's a difference is the hotter air going into the second stage. Okay, so we came out of the second stage at 380 and then went into the aftercooler. Okay, we came out of here at 380, came down this pipe, went into the aftercooler, through the aftercooler, and out and into the tank. Okay, so we went from 380 into the aftercooler down to 131 going into the compressor. We dropped the heated compression roughly 250 degrees. Okay, from that point we get additional cooling. The air, even though we were running full flow and this machine's rated at 72.5 CFM, still cooled down the compressor tank. And by the time we got to the discharge back here, we cooled down to 107 degrees. So what we have for the compressor itself, which is this whole area here, we have a temperature rise of 17 degrees. And that's just exactly right where the machine's rated at. Okay, now we came out of the compressor tank into the remote tank behind me. The air cooled in the remote tank another 11 degrees down to 96 degrees. The 96 degree air then went in the dryer, and the dryer, as I mentioned, is a piece of equipment that's really temperature sensitive. Before I take off this cover, we've already taken all the bolts off, I want you to notice these two lines. This device here is called the pilot valve. It operates in unison with the centrifugal unloader. This piece of copper tube here leads directly into the high pressure cylinder. Goes from the high pressure cylinder into the pilot valve. And when the pilot valve operates, it exhausts up through this tube, which leads it back into the low pressure cylinder and eventually makes its way out the intake filter. Okay, just note that this tube here went to the high pressure cylinder, and this tube, for all practical purposes, is an exhaust. Okay, let's get this cover off. And I also point out, when taking off the crankcase cover, we've already drained the oil, obviously. Watch out, because there's a guard, a splash guard, that protects the oil level switch float. and that's right here. This cover goes over the oil level switch. That's there to prevent the oil level switch from bouncing around when the machine's being lubricated due to fluctuations in oil level. Okay, the first thing you notice is this centrifugal unloader. This is the unloader we talked about when we talked about the standard unloading system on the machine. I'll go real briefly into how it works. Okay. Right now the machine's at rest. When the machine is started at 400 RPM, these two weights will fly out. Now when they fly out, they also move this plate in. It's this in and out action of the plate caused by the unloader weights, which actuates the pilot valve, which in turn unloads the compressor. Okay, in the stopped mode, that plate is all the way out. That plate being out would push this little valve, the pilot valve plunger, in. By pushing this valve in, what it does is it bleeds the line from the high pressure cylinder through the unloading valve and exhausts out your inlet filter. It exhausts all the pressure off your high pressure cylinder. That's the way the machine, as standard, unloads. Then when it comes up to speed at 400 RPM, that plate goes back, the pilot valve plunger goes back and shuts off the airflow from high pressure cylinder. The machine will not bleed off any air and it loads up. Now when we did those amp draw readings, we saw that after the amperage initially went up to a 220 amps, whatever it was, it stayed at about 150 for quite a while. The reason it did that is this machine's standard operating speed is just a little over 1,000 RPM. So after it came up to 400, the machine loaded. And it loaded before the motor was fully up to speed. So that amperage stayed up a little longer. Okay, that's about it as far as the centrifugal unloader is concerned. Notice on this crankcase that there's no rear bearing carrier for the crankshaft. The design of this machine is what's called an overhung crankshaft. And what I mean by that are both bearings are overhung of the counterweight. I've got a crankshaft out and I'll show you. We got one shaft right here. This is the overhung principle. Okay. Two bearings or ball bearings. Your flywheel would typically bolt right to here. Bearings are supported. Your counterweight, and then your journal. All three rods, your two low pressure rods and your high pressure rod, all three of them fit on this journal. They kind of go, they're stacked like that. Your high pressure rod, since it's a smaller piston, does not have quite the journal area as your low pressure rods. They just go right over and fit on. Part of the design of this crankshaft is that it enables us to use a replaceable rod journal. This just slips off. Now the advantage of that is that for some reason this machine ever runs low on oil, the first thing that'll go will be your rods. Now typically with a design that does not use a replaceable journal, you'll score up a crankshaft, and that's by far the most expensive part of the compressor. With this design, the journal is replaceable. If you score it all up, just pull it off, throw it away, put on a new journal. On the end, in here, is where that centrifugal unloader we just showed you bolts on. Okay. Rods are one-piece rods. They're not like automotive type rods that are split and use some type of insert. They're one piece. They're cast one piece, precision drilled, to never go out of alignment. Notice also this projection on the bottom of the rod. That's called a dipper. This machine is a splash lubricated machine. As the crankshaft turns, and these rods are going up and down, the dipper dips in, picks up the oil, and what it does is establish a real dense oil fog in the machine to lubricate all your parts. Since we're not pulling these things out of the machine, we're showing you separately. Here is a piston. This is a low pressure piston. The wrist pin. It's made up of two oil control rings, or excuse me, two compression rings, an oil scraper ring, and an oil control ring. So you have two compression rings and two sets of oil control rings. That's what makes up your piston. You know, it's very similar to an automotive type piston. We use a little bit different oil control rings, but again, very similar in design. The two low pressure pistons are made of aluminum. The high pressure piston is made of steel. The reason for that is the high pressure piston sees higher heat, plus it's made out of steel to get a little better running balance on the machine. You weigh the high pressure piston versus the two low pressure, your weights aren't going to be off by a great extent. Okay, this is where we have the problem with running a machine on constant speed control. In other words, where it runs continuously in an unloaded mode. The design of this piston is such that to have efficient oil control, you have to have pressure on top of the piston. If you run a machine for an extended period of time under no load, what will happen, oil will eventually migrate past the oil control rings and puddle on top of the piston. I think you'll note on your machines that you have that run constant speed control and run unloaded for a great extent of time, you get oil dripping out of your inlet filters. The reason for that is that oil is puddling on top of the pistons and just gets puddled to the point where it just leaks out. That, again, was one of the reasons why we went to basically a start-stop system, to avoid the oil puddling problem. And it's a problem that's not just true of an Ingersoll Rand, it's true of any of this class of equipment that has a single acting piston, a piston that compresses on one side. Okay, let's take a second to go through the operation of your low oil level switch. Your low oil level switch is simply a float operated device. I don't know whether you can pick up this little clicking. The way it works, the float floats in the oil, it's connected to a shaft, and in turn is connected to a micro switch. The way this is installed, I've got another switch here that I've just taken out of parts. The switch, this screws in to the casting, and then the float part clips in, like that. So often people figure they have a defective low oil level switch. They don't take off the back of the crankcase, and they just start unscrewing the switch, and they always twist off the float. Then they have a real mess in their hands. Okay, we've had reports, or one of the basic problems that we have with the machine is misadjustment of the low oil level switch. It probably compromises 80% of our calls. Okay, a typical problem. This last winter, there was a lot of cold compressor rooms. When you shut the machine down overnight, maybe the doors didn't seal very well. A lot of times there aren't any heaters in these compressor rooms. What happened? The room got real cold, oil gets real thick. And the machine initially starts up in the morning, and the old splasher starts splashing the oil up. It's thick. what it does, it splashes the oil up on the sides of the crankcase, and it doesn't flow back down to the bottom real fast. So what happens, you start up, the thick oil goes to the sides of the crankcase, and your lower level switch drops down. It signals that you're out of oil, so the machine shuts down. It's kind of a nuisance type thing. You know, if there's one thing that you people do, it is you religiously check your oil. So as long as you understand how the switch operates, in the wintertime, it's just a simple, the solution to the problem is just simply setting the float maybe a little deeper in the oil so you don't get this nuisance shutdown. Okay, we'll go through how to set it. I've already loosened up the screws on this and removed the cover. The way the switch works, as it goes up and down, it activates, this lever is connected right to a micro switch. Okay. When the float is up, it activates the micro switch closing the circuit. When the float goes down, signaling it's out of oil, the micro switch opens, breaking the circuit, shutting the compressor down. Now we set these when they leave our shop, but they're not really always exactly the way they should be. So if you ever have a problem with a lower level switch, the procedure is remove the cover, we've already done here, loosen up these two screws. Now by loosening those two screws, you can rotate the switch assembly. Okay, like right now, well, you can rotate all the way this way, and the contacts will be made even when you're out of oil. That's obviously over adjusted. If you rotate it in a counterclockwise motion, you can get it to right where you want it. What you want, when it's filled with oil, this float is almost all the way up. When she runs low, just for the contacts to open, like there. If you experiment with it a little bit, you'll see what we mean. It's a fairly, for such a simple switch, it sure represents a lot of problems and misunderstandings. Okay, that pretty much covers all that's involved with the crankcase, running gear, the centrifugal unloader, and the oil level switch. The next thing we'll deal with is the valves. What you're looking at right now is one of the low pressure valve and cylinder assemblies. Okay, with the Ingersoll Rand design, your intake and your discharge is all done on the compressor cylinder. There's air passageways cast into the cylinder itself. The reason we do that, and this is an exclusive with Ingersoll Rand, is so you can undo your head bolts and remove the entire valve and head assembly and be able to inspect your cylinder bore without having to break any external piping. Because of this, it's a little hard to visualize just where the air goes inside the valve. To give you a little bit better idea, I'm going to remove this and try to point out the air path. Okay. As you can see, the air comes through the inlet filter here. You notice the gasketed side into here. This is the intake porting for the intake. This valve plate here, it's really more of an air manifold. Inside the assembly, it manifolds the air to come to these little holes, and on the outside is the intake area. The air, after it comes through here, comes out around here through these little holes. Goes down into the cylinder on the suction stroke. On the compression stroke, comes up and goes through the big holes in the center. Air goes through the holes, in through manifolding inside the valve plate, and out through here. Through here, goes out through the discharge port on the cylinder, and down in to your manifold. This is the manifold for both your low pressure cylinders. The air then, of course, goes to your intercooler and your high pressure cylinder. Now what I'm going to do is disassemble this, give you an idea of the air passageways and just specifically how the valve works. On the table in front of me is a completely disassembled valve. This is an intake valve assembly. Same thing as a discharge valve, with the exception the parts are a little bigger. Okay, here are your valve seat plates. This is your inlet valve plate and the corresponding spring, your discharge valve plate and the corresponding spring, valve seat plate, which does the manifolding of the air, and the valve cover plate, which also aids in the manifolding of the air. Behind is an unloader assembly, which I haven't disassembled yet. Okay, what I'm going to do is put this valve back together, and as I go, explain to you how it works. Okay, the first thing involved is putting your intake, spring, and disc. They fit just like that. Your discharge valve seat, that, and then top plate. Make sure everything fits in there. Just like that. This comes a washer, hold down bolt. Now I'm just going to remove these and show you the side view how the air discharges. Okay. The air comes through the large holes. As it comes through the holes, it pushes against this seat. It comes up to pressure, pushes against the seat, comes out around the outside of the valve plate and also through the hole. Air pushes the valve open, comes out and out. Okay, the intake goes the same way except in the opposite direction. The intake valve fits just like that. I'll try to hold this. You can see across there. When you suck air, when air is sucked into the valve, where the air comes through this passageway into this area and then goes down and through there. The air then, look on the side view, on the suction stroke, goes in and pushes that plate open. The air travels over the outside of the valve plus through these little holes on the suction stroke. Okay, these plates, you'll notice, we sucked in through this hole, through this area here. The air goes into the valve, and it discharges through the center of the valve out through here. Now, to keep all the air in the right passages, the cover plate. Okay. You'll notice if you take this apart, you have to make sure your cover plate is lined up properly. It's automatically done for you because there is a guide on the back side which fits right in the back side of the port. You notice just follow the airflow in the gasket. That goes over the top. That. And there's an acorn nut. Holds the entire valve assembly together. And when you install it on the machine, note that there's the in, which would go towards the inlet filter, and the out, which would go through your intercooler. Your lines are all lined up. That's basically what's involved with the valve. The next thing we're going to cover is the unloader assembly. What the unloader assembly does is when air pressure is shot into it, it pushes down this fork, and it holds your inlet valve open. By holding your inlet valve open, you unload the compressor. Because with an open inlet valve, when the piston comes on a suction stroke, it sucks air in. When it goes up on its compression stroke, it blows it back out the inlet. So that's what we mean by an unloader. It just simply holds the inlet valve open. I'll disassemble this. Same as the cover. Simply the air goes through the openings on the inside of the cover. Okay. When the air comes in through the top cover, it pushes down on this piston. I'll just back this out. Okay, the piston is just simply, it's like a Bakelite type material with an O-ring. It travels in this cylinder. When air is on top of it, this pushes down. Okay, it pushes down this spring, which in turn pushes down this fork. Down. It doesn't quite push it that hard. Okay, to a stop from over pushing is the reason we're having the springs on one end, and then as the fork goes down, there are springs on the other end. Oh, there it is. Now, this fits into 3 holes in the inlet valve, just like that. Of course, this whole assembly we bolt it together, bolts on top. So when air comes to the unloader, it pushes this down. Now, looking from the side, you can see when air is put on it, it pushes the valve open. Watch right here, watch the disc. There, it's just held open. Okay, just a very simple assembly, and the only thing it does is pushes down to hold the inlet valve open. Note, it takes air pressure to unload the machine. When you exhaust the pressure, the springs on this fork pick it up off the valve and operates on normal. All 3 of the unloaders, the 2 low pressure and the 1 high pressure, are all hooked together, which are tied into the unloading system on the control panel. You've seen the complete assembly and disassembly of the valves. You might get the idea that once you have problems, it's a fairly easy thing to fix because there's not a whole lot to putting the valve together. Basically what you're doing is replacing these seats. It's not all that easy. When a valve is worn or dirty and it starts leaking, the proper way to do a valve job is to resurface the seating areas. I think you can probably see on here where the intake valve normally seats against, and you have to have a good seating surface so you don't leak. You can see these little marks there, up through there, all the way around the valve. Those are the seating marks. You put on a new valve disc, odds are it's probably going to leak because it's not really going to match up with the surfaces on the valve. This is where a lot of people go bad on doing their valves. They don't remachine their seats. You can't really, you can remachine your seats, but you have to know what you're doing. If you machine them down too far, you start lousing up your clearances. Because of that, what we're going to do, once we determine the life of the valve assemblies, is we're probably going to have an exchange program. And with an exchange program, the only thing you people have to know is how to pull this off and put on a new one. That'll be the extent of your valve knowledge. And that way, you'll have, that normally puts the machine back in tip-top shape, because these piston rings last a very long time. lastly, since I have filter assembly disassembled, real quick, the air goes through these tubes in the back side. There's the cover comes over here, sucked through the element, and down in the machine. Very simple. I think the first place to start with on the control panel is on the various items on it and what they do. Okay. First item is the hour meter. Its purpose is to record the running hours on the compressor. It's simply tied in. Whenever the motor starter is on, the hour meter is activated. By using the hour meter, you can get an idea of how much air you use. You can use it for maintenance, because like the air filter should be changed at a certain period. It gives you a good idea of when things should be done in the machine. Okay, the next two items are the on switch and the off switch. Okay, these are identical switches. They're just simply a push button. Okay, by turning the compressor on, really what you're doing is you're turning the compressor's control system on. Remember, your pressure or your compressor automatically starts and stops based on system pressure. So just because the on switch is on doesn't necessarily mean your compressor is going to be on. What it means is that the control system is activated and the compressor could start. And when you push the off button, what you're doing is shutting off the control circuit. The compressor cannot start. Okay. Then we'll open her up, take a look on the inside. Okay, the first thing you see in the big item is the motor starter. Now, the purpose of the motor starter is to carry the starting amperage of the motor, which, if I remember right from the last tape, runs about 220 amps. Okay, what is inside of this, since it's a three-phase starter, are three contactors. That when the compressor gets a signal to start, the contactors close together, and there's enough metal in them to handle the starting amperage and the running amperage of the motor. Okay, and the bottom section of the starter is the overload block, which has, people call them the heaters. The purpose of the heaters is when the motor is under an abnormally high current. What happens? These heaters heat up, and once they heat up, there's a mechanism within this overload block which shuts the compressor down. Now, once the compressor shuts down, these heaters will cool, and then you can reset it, and the machine can start again. So the purpose of the overload block is to protect the motor against abnormally high currents. Okay. The top item is a control transformer. It's a tri-voltage rated transformer. That means it will give you your 110 volt control circuit with either 208 volt 3-phase, 230 volt 3-phase, or 460 volt 3-phase, depending on how you wire the components together. It's a tri-voltage rating, so basically the same control panel can go to any job site, and in the case that the job site ends up being 460, you can change the leads to still have 115 volt control. Its main purpose is to provide 115 volt for your compressor control system. Notice also on the top here, what we have done is we have just a plug to run 115 volt to simulate the control circuit working. Okay, first item you see is PVR, phase voltage relay. Its purpose is to protect the motor against phase loss. I think we covered it quite extensively in the last tape. The next two items are your T1 and T2 timers. The purpose of the T1 and T2 timers are to unload the compressor and provide a delay on coming up to speed. The T1 timer is set at 8 seconds. It's wired in with the unloading solenoid down towards the bottom of the control panel. Okay. When the T1 timer is activated, the unloading solenoid is activated. which takes air from the receiver, compressor receiver tank, in through the unloading solenoid and to the head unloaders. Now, when the system gets a signal to start, T1 is activated, and for 8 seconds, unloading air is being applied to the head unloaders and the compressor. Okay. T2, it's set at 4 seconds. It is simply a 4-second delay for your motor starter. The reason for the delay is that when the compressor gets the signal to start, we want 4 seconds to assure that the air gets through your control air lines, through the unloader, and make sure the machine is totally unloaded prior to starting. Okay, at the end of the 4 seconds, when the T2 timer times out, that's when the main contactor is activated and the motor starts. Okay. The R1 relay is there basically to provide the remote off function of the control panel. Remember, this control panel is set up so the system can be shut down from a remote location. Well, to do that, we had to use this relay to give a 3-wire control, and we'll explain that a little bit later on. The R2 relay, the function of it is to provide an on-off for the ventilation fan controller. When the control panel is on, the R2 relay is activated, which will allow the ventilation fan controller to work. At night, when you shut the system down, the R2 relay is deactivated, which deactivates the ventilation fan controller, shutting the exhaust fans down. We don't want them running at night when there's really no reason for them to. The R3 relay is a 24-volt DC relay. It receives its signal directly from the show computer. The R3 relay is wired in conjunction with the PS2 pressure switch. When the R3 relay, when used in conjunction with the PS2 pressure switch, allows the compressor to run on what's called constant speed control. What constant speed control is where the compressor motor continuously runs, but the compressor simply loads and unloads basis a rise or drop in pressure. We have that in case we're running an extremely long birthday skip, for example, where we don't want the motor to be starting and stopping too often. What we'll do is there'll be on the show tape for that particular song a 24-volt signal, which will be shot to the control panel, activating the R3 relay. When the R3 relay is activated, PS2 is in line, and the machine will start up and run on constant speed control. Now, PS2, all it really does is activate or deactivate the unloader. Remember, the motor's already running, so when PS2 comes up to pressure, in this case, which is 130 pounds, it activates the unloader. The unloader sends air to the unloaders on the compressor heads and the machine coast. When the pressure drops to 110, PS2 closes, which deactivates the unloader, allowing the compressor to load. So the R3 relay activates the PS2 pressure switch, allowing the machine to run a constant run. Okay. We come over to the PS1 pressure switch. This is the main start-stop pressure switch on the system. It's set to turn the compressor on at 100 pounds pressure and off at 190. Okay. Also notice that in the socket strip plus the terminal strip, there's a spare socket plus 5 spare terminal locations. We did this because there's no telling what the future will bring. We want to have the capability of very easily in the field adding a relay with the associated terminals in case a change comes up. Okay, the only other thing we haven't covered on this is the control circuit fuse. The purpose of this fuse is basically to protect the transformer against some malfunction in your controls so you don't burn out the transformer. Now, that pretty much covers everything on the inside of the control panel. Now, let me take a moment just to explain to you how some of the various components work. thing I think I'll start with is the on-off push button. Again, I mentioned they're identical push buttons. What makes this a special push button is the fact that it's a transformer operated button. In other words, the pilot light is not a 110 volt light, it's a 6.3 volt light. It just pushes in and twists, very similar to the lights on the backup lights on a car. Okay? The on-off button are identical, it just depends where the wires are led, either a normally open or normally closed side of the switch. These top two connections are actually connections for the pilot light. Again, it's a transformer operated light. When the bulb eventually burns out, now with the transformer light, it should last a very, very long time. But when the bulb eventually burns out, you'll want to replace it with a bulb that's rated at 6.3 volts. And you can get it by any electrical supply house. The next item I think I'll show you is actually what one of the overload heaters look like. What this is a ratcheting device on the top here that is set in a cylinder. Basically, the cylinder is filled with solder. Now, it's all bases your amperage and your heat. When you're pulling a lot of amperage across your motor, you're generating heat. And what the heat will do at a certain amount of amperage for a certain period of time, the solder inside of this will heat up and melt, allowing this little sprocket on top to spin. When it spins, there's a little latching mechanism in your overload block, which then shuts or opens a set of contacts, shutting the system down. Now, when the system shuts down, what happens is the solder inside of here will solidify. So when you push the reset button, the ratcheting mechanism resets itself on this gear, and the machine can then be restarted. Now, there's been a couple of instances where people have had problems with the overload relays. One of the problems is when you're into a very hot compressor room, that's just that much more heat that's put onto this overload heater. So you tend to get a nuisance trip. And if these things trip often enough, they tend to lose their stability. In other words, they'll start tripping at less and less amperage. Generally, they say about half a dozen trips and it ought to be replaced, because it just, your reliability, you just lose it the more you trip it. Okay, the next item, and maybe the item that's the most confusing, is the pressure switch. Okay, now what we have here is the PS2 pressure switch. The PS2 and PS1 pressure switch are pretty much identical, with the exception that PS1 has a much higher pressure capability and wider differential setting than PS2. Now, what I mean by differential, I'm talking about the difference in pressure that the compressor can turn on and off. A wide differential, which PS1 is, allows the machine to run against a 90-pound pressure differential. Kicks on at 100 pounds, kicks off at 190. PS2 has a narrower pressure differential. It's designed to operate for basically a 20-pound differential between 110 and 130 pounds. Okay. The way to set the pressure switches: the top screw adjusts the cutout pressure of the switch. By turning the screw clockwise, you increase the pressure setting of the switch. By turning it counterclockwise, you decrease the pressure setting of the switch. The bottom screw is your differential adjustment. By turning it clockwise, you decrease the differential of the switch. By turning it counterclockwise, you increase the differential on the switch. Okay, now when adjusting the switches, the first thing you want to do is adjust the cutout pressure. So typically you would bleed your tank down on your compressor, turn the top screw up. Now you'll also notice on the side is there's a sliding bar scale. that gives you a rough indication of about what pressure the cutout is. So what you would do is turn the top screw clockwise until you've got the pressure right to where you want it, which would, let's say this is PS2 at 130 pounds. You would turn your compressor on and let it run until it unloaded in the case of PS2. Now if it ended up being at 135 pounds pressure, which is a hair too high, all you would do would be back to screw off one turn. And the reason I say one turn is so you always have a reference point of how much one turn is. You come up to 135 pounds pressure, it's too high, back to screw off one turn. Bleed the air from your receiver tank, dropping the pressure. The compressor will reload, and as it comes up to pressure, you'll just note at to what pressure it unloads at. Remember, you turned it one turn. So if it comes up and shuts off at 133 pounds pressure, you know that one turn is basically 2 pounds difference. It's just an easy way to set that cutout pressure fairly quick. Now once you've established a cutout pressure, the way you establish the cut-in pressure is with the differential. Now what you do, again, you would turn it to one direction, let's say maybe midway on its band. Went too far. Okay. Again, drain the air out of your compressor and find out at just what point the compressor reloads itself. Okay, and if it ends up loading itself too high or too low, you change the differential accordingly. Now once you get the differential set for the compressor to kick back in at 110, the cutout pressure may float a little bit. And from talking to our servicemen that set these prior to sending them out, evidently it's within a turn or two. So it's kind of a two-step process. Number one, you set your cutout pressure, then you set your differential, which will dictate your cut-in pressure, and then you might have to fine-tune your cutout to find out exactly where you're at. It takes 2 or 3 adjustments of each screw to get to just where you're supposed to be. Okay. The first thing we'll start with, up at the top, is the motor starter. Now we have L1, L2, L3, T1, T2, T3. Okay, in between are the normally open M contacts. What those actually are is the contactor in the motor starter. Now, you'll notice down a little bit when you eventually get to the bottom of the diagram, the motor starter coil. When M is eventually activated right here, these normally open M contacts close. Now notice there's nothing connected to L1, L2, L3, T1, T2, T3. These will be your 3 main incoming power leads, and the 3 leads back to the motor. These little squiggly designs here is the design for the overload heater. Okay. Now also while we're up here, the PVR, the phase voltage relay, picks up its 3 leads on L1, L2, L3. A wire goes from L1 to number 3 on the PVR, and again this will be on the socket, the PVR socket. L2 goes to number 4 on the PVR, and L3 goes to 5 on the PVR socket. The 3, now these are, remember, line voltage leads coming into it. This way the PVR will sense your phase loss and your voltage differential. Okay, coming off L1 and L2, we come down to our control transformer. Now, we go L1 goes to H1, L2 goes into H blank. The H blank, remember this transformer is good for 208, 230, or 460. So to determine just what location on H, you go down to the bottom, which is the transformer wiring. Okay. Now, since we're running, the panel we got in the shop here is 208 volt. So what the leads, L1 will go to H1 and L2 would go to H2. Now if this was a 230 volt, wired for 230 volt, L2 would go to H3. If it was a 460 volt, L2 would go to H4. You notice X1, X2 do not change. Okay, going back up then, since the panel we have here is a 208 volt and 99% of all these control panels are 208 volt, this would say H2. Okay, so we come in with line voltage, H1, H2. We come out, X1, X2, with our control voltage, which is 115 volt. Notice hooked on to X2, this is a grounding sign. There's a wire that goes direct to ground from H2. And by ground, just to the compressor control panel. That's per code. The X2 side is really our neutral side. Everything throughout the control panel, remember when we drew that little diagram, a sample diagram, everything has to eventually find its way back to neutral. All these eventually lead back to X2. Okay, on the hot side, the first thing we come out of on the transformer is a fuse. Now the fuse will vary depending on the size of the control transformer. Right now we have a 350 VA controlled transformer, therefore we're using a 3 amp fuse. There's a supply problem. Once that gets straightened out, we'll be using a 250 VA transformer, which will use a 2.2 amp fuse. Okay, come out of the fuse. Now let's go down from the fuse, one wire, then goes to the darkened, the heavy terminal 1 and 2. This is where the remote on-off switch is in the circuit. Notice that it's the first thing in the circuit. So when this is off, all the circuitry downstream is it's dead. The unit is off. So when remote off, which is located typically in the computer room, is off, your entire circuit is closed. Okay, we come then, you would make your connection between 1 and 2, and we come over, there's a wire that goes to terminal 10, but we're not too worried about it. Then the E. E is one of the locations on the off switch. Through the off switch to location F. Notice the off switch is a normally closed type switch. The on switch is a normally open. When you push the off switch, you're breaking this connection. When you push the on switch, you're making a connection. Okay? Now, when you push the on, notice when, we'll go back just a little bit, let's assume the on switch, the remote on-off switch is on. So current is coming through the wires, through the off switch, all the way up to the on switch. Now you depress the on. Once you've depressed the on, notice you've completed the circuit through to the R1 coil. And the R1 coil is connected to 13, and then it goes just back up to ground. So as soon as you depress the on switch, you activate R1. And immediately, as soon as R1 is activated, the normally open R1 contacts close. Now when the R1 contacts close, that allows the current to go through the off switch. Remember, now you push the on switch and have let it loose. So no longer is there continuity between C and D. However, when you push the on, you activated the R1 relay, the normally open R1 contacts closed, and the current then goes right through around the on switch. This is what we're talking about by a 3-wire system. You got 1 wire in, 2 wires out. By pushing the on switch, you activate the R1 relay. The R1 contacts close, which seals in the circuit around the on switch, and you're running. Okay, at the same time, when you push the on switch, the R1 relay is energized, the R1's contacts close, you also activate the R2 relay coil. And again, now it's just goes back to ground, back to the system. Now up on top are we call it here the exhaust fan contacts. They're actually the contacts for the ventilation fan controller. When R2 coil is energized, these normally open R2 contacts close, and we've got them wired in parallel here for a little more amperage carrying capabilities. So all this really in effect then is really kind of an on-off switch for your exhaust fan. When you activate by activating R1, R2 is in turn activated, which will close the circuit and the exhaust fans will run. When you deactivate R1, R2 is automatically deactivated. These open up and the exhaust fan shuts off. Okay, going down back to what happens. Now also when you hit the on button and R1 is activated, closing the R1 contacts and you've got current, current also then goes back around and turns on the on light, the green light, which is between A and B on the on button. And of course, they just go back to ground. Now, a little bit up above, you notice there is a normally open R1 set of contacts. Going back from the beginning, these originated directly downstream of the fuse. Coming out of the fuse. As long as the R1 relay coil is not activated, current will flow through R1, which then activates the off light. And from there, again, it goes back to ground. So two things happen. When you push the on push button, by activating R1, you activate R1 normally open R1, which closes R2. You also turn on the on light, and the normally closed R1 contacts open, which turns off the off light. That's how your on-off lights are activated. Okay. Now, the way you break the circuit, you know, it's the only way the off light can come on is if the R1 contacts, if the R1 relay is de-energized. And the only way you can de-energize the R1 relay is to back up through the circuit back to the off switch. So when you hit the off switch, you break the circuit here, which in turn deactivates the R1 relay. When the R1 relay is deactivated, it deactivates the R2 relay, which shuts off the exhaust fans. Your on light goes off, and then your off light comes on. Okay, there's all this circuitry just has to do with the on-off, basically the lights and the remote off and the exhaust fan contacts. Now let's assume that we're on, and we've got circuit, continuity through the circuit, through the R1, everything up above has been activated, and we come down to the compressor controls. The first switch we come to are the contacts for the PVR, phase voltage relay. Now, the phase voltage relay, again, is sensing your three phases. As long as we have all three phases, this will be closed. With this, if you have all three phases, this will be closed and current will go through there to your PS1 pressure switch. Now note, once you lose a phase, this opens up and your circuit dies right here. Your lights, your on-off lights will still be on, but nothing will happen because the circuit died right here. Okay, let's assume you have all three phases and the PVR contacts are closed. The voltage comes through PVR into the PS1 pressure switch. Okay, now we've got A, B, and C. Notice nothing's hooked to C. That's why there's only two wires on the pressure switch. Well, when the pressure drops to 100 pounds, which is the on setting for PS1, the voltage will go from B through A and on to the rest of the circuit. Now, when the pressure rises to 190 pounds, the circuit is broke at PS1. B goes up to C, which just opens the circuit, and everything stops. So let's assume that we have 100 pounds pressure and PS1 just closed. Okay, the circuit now has to go through the oil level switch. Again, this is another safety device that's customer installed between 7 and 8. If there is oil, if the compressor runs low on oil, the contacts open on the oil level switch, and the circuit's broke between 7 and 8. Well, let's assume that you have oil. So oil level will rise, and you'll have continuity between 7 and 8. Okay, now you have continuity between 7 and 8, and you come down. Now when you come down from 8, everything is activated. Well, everything has the control voltage to it. So you come down from 8, all the way down, and see, these are just contacts, so nothing's happening with the contacts. What happens is the T2 and T1 timers are activated. Okay, remember I told you that the diagram of the timers is is identical to the timer on the relays. The T2, this is actually the T2 timer is its coil, and the coils are 2 and 7. 2 and 7 on T1. Again, they go back to ground, and that's how they complete their circuit. So when PS1 closes, there's oil in the compressor, so the circuit goes all the way down, activates T1 and T2. Now what T1 and T2 are on-delay timers. Now what I mean by an on-delay timer is when it gets its signal, there's a delay before its contacts transfer. Let me say that again. Whereas when this coil is energized, in effect what you do is energize the timing circuit. Once the timing circuit times out, that is when all the timer contacts change. Okay, now let's go through each one. And we said, well, T1 and T2 are both activated at the same time. Okay, we'll go up to here. So when T1 is activated, this normally open set of T1 contacts stay open through the timing cycle. Okay, they come through here, and then the next thing they come to, notice, is the R3 contacts. R3, we're going to go up above now, are for the computer signal. When the show computer sends a 24-volt signal to terminals 5 and 6, they'll activate the R3 relay. By activating the R3 relay, they'll come down and close this normally open set of R3 contacts. So now, we're starting the compressor. Let's say we're not using the 24-volt signal. So our R3 is not activated. R3 contacts just stay open. So that circuit just dies right there. Okay. Now we would come down. Next thing is the normally closed set of T1 contacts. Remember, T1's in its timing cycle, and T1 is set at 8 seconds. So T1, this normally closed set of T1 contacts is not transferred because its time is still timing out. So current then goes through the circuit up to the unloader, the UNL, the unloading solenoid. The unloading solenoid now is activated. And when it's activated, it's sending air to the compressor unloaders and the machine's unloading. We'll go through the compressor. We'll go through this on the actual control panel to show you. Okay, so through this circuit here, during the time cycle, current goes to the unloader and the machine's unloaded. Okay, now we have the set of T2, normally open T2 contacts. T2 times out in 4 seconds. So for the first 4 seconds, nothing happens. After the 4 seconds time out, these both close. When this normally open set of T2 contacts close, you'll have current that then goes to B&A, which is the motor starter coil, goes through your overloads. Now notice these overloads are all normally closed because we assume, the way I remember I mentioned how the heater worked, they were always closed until you had a malfunction, then they opened. So when you're not in any type of failure state, they're closed. Current goes through there and just eventually goes back to ground. So as soon as T2 times out, that closes, and in effect you activate the motor starter coil. The motor starts. Okay. On the other set of T2 normally open contacts, they close, and all they simply do is turn the hour meter on. Okay. Now let me go through real quick, just up at the beginning here. PS1 closes. The compressor gets the signal to start. The current goes through the oil level switch, comes down, activates T1 and T2. T1 is set at 8 seconds, so immediately, since we go through this normally closed at T1, the unloading solenoid is activated. The compressor's unloaded. 4 seconds go by, T2 times out, both these set of contacts close, the motor starter starts, starting the motor, and the hour meter is started. Then 4 more seconds go by, which is the end of the 8 seconds for T1. Both these contacts change. This set of T1 opens, And when you open it, what you do is the unloader is now, it's deactivated. And when the unloader is deactivated, it vents the air from the unloaders and the machine pumps. Also, this normally open set of T1 contacts closes. So now you have current right down to the R3. Compressor's running. Now let's assume that the show computer sends a 24-volt signal up here to the R3 relay. It sends 24 volt, the R3 relay is energized. And we come down to here. Remember, the compressor's running right now. R3 relay is energized, the contacts close, the machine's running, so the current goes through the T1, through R3, and now to PS2. Now the setting of PS2 is 110 to 130. PS1 was 190 to 100. So your compressor's running, you're making pressure. Now let's say as the pressure is rising from 100 to 105, 110, 120, and then when it hits 130 pounds pressure, PS2 will go, instead of the BA, it'll go to the BC position. It opens on a rise. It comes up to 130 pounds pressure, PS2 rises to the BC, and the unloader is now activated. The unloader is activated, which sends air to the compressor and unloaders, and the compressor is unloaded. It's just coasting. Well, if you're consuming air, the pressure, of course, is going to drop. So as the pressure drops, eventually PS2 will go, when pressure drops to 110, PS2 will close between B and A. When it closes between B and A, you've broke the circuit on the unloader. So by breaking the circuit on the unloader, the machine pumps. So it'll pump up to 130 pounds, whereas PS2 will come between B and C and unload. This is the constant run mode. Now, once the R3, once the current or the 24 volt DC signal is removed from the R3 relay, R3 will open. Now that R3 is open, PS2 does not enter into the circuit anymore. So the compressor will run and run and run until PS1 comes to 190 pounds pressure. When PS1 comes up to 190 pounds pressure, its contacts will switch from BA to BC, which just leaves it open, and everything shuts off. Your motor coil is deactivated, your timers are deactivated, your armors, everything shuts off. Also, there's the timers, T1 and T2, each time current is taken off them, they reset themselves for the next starting cycle. Okay, the first thing will happen, well, as soon as I do it, T1 and T2 will be activated. After 4 seconds, T2 will time out, the light will go out, and you'll hear the starter. It's the starter activate, which would be the motor starting. 4 seconds later, at the end of the 8-second cycle for T1, the unloader will vent. Now let's go through it. Here we go. We just started. Everything's activated. T2 just timed out. Motor running. T1 still timing. T1 just timed out. The air from the unloader was vented, and the machine is running. Okay, now the machine's running, 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 till we eventually get to where PS1 is up to 190 pounds, so the system shuts down. Okay, now I shut it off by just pushing the off button. If PS2 would have, or PS1 would have shut the system off, the relays would have always stayed lit. Because remember, PS1 and 2 are downstream of your on-off circuit. Okay. Now, we'll go through it one more time, and what we'll do, we'll focus in on the unloader just to show you that air is going over to it. Okay, here we go. Compressor sitting unloaded. We start. Air is immediately sent to the unloaders. The motor started. Now, after 4 seconds go by, air is exhausted the compressor.